more like all the characteristics of therefore it is okay, it's all yeah. I wish you like I'm with you. And I'm maybe here for all the time. But it's
Yeah, we're on time. Welcome to our next speaker, James Ladyman, author of this famous or infamous book, the very first book that laid out the land of Ontic structure of realism, I believe. Most people, they think about the first polemical chapter, but that's only one chapter. All the rest is extremely constructive, isn't it, James? Excellent. I give him the floor. Natural necessity is just the stuff for Ontic structural realism.
Right, good. Thanks very much, Fred. Thanks for the comments. Thanks to everyone. I kind of always like to think of a pun in a title and then build a talk around it. It's a particularly good one, but here we are. So, by just the stuff. I know we have this expression in English, you know, that's just the stuff. You mean that's good, that's what you want, that's what you need. But obviously stuff is like a synonym of, I don't know, matter or substance in a non-technical context. And so what I'm really saying is something like, insofar as there's a substantial or non-abstract sort of component to the metaphysical commitments of structural realism, it's natural necessity. Okay, so that's my headline. So I'll say what I mean by that, so you don't understand that yet. That's right. So I want to point out, I mean, Ontic structural realism, and we already heard this yesterday when Kerry was characterising Ontic structural realism, and I was sort of slightly objecting and saying, well, you know, you characterise it in a positive way, you characterise it in a negative way. And lots of philosophical theses are more defensible when you characterise them negatively than positively. Right? So if you think of something like empiricism, you know, I'm on much better ground defending the claim that there's no substantive a priori knowledge than I am claiming that all knowledge comes from experience. It's sort of technically easier to defend the negative. So there's that, but there's also the fact that Ontic structural realism has been developed in really quite different ways by Stephen and myself with Don Ross. And I think that, you know, caused a bit of confusion because obviously, well not obviously, but Stephen and I also did write some stuff about Ontic structural realism together. And so people can be forgiven for thinking that there's a single view which Stephen and I share because we sort of developed it together and argued for it together. But then equally, we say very different things now about some things. So it's nice that Steve's coming after me, and he'll be able to say if I've sort of mischaracterised his view. I mean, I think we agree about a lot, but I'll be talking about some of the differences. And one of the differences, I guess, is that one of the most important differences is that when I wrote Everything Must Go with Don Ross, I had we had a bigger target in mind than physics, right? So lots of people would say, oh, on structural realism, you're just overgeneralizing from a few cases in physics, or it works for physics, but it doesn't work for everything else, and that kind of thing. And I just made it clear from the outset that in that book, we were not just thinking about physics at all. We're trying to give a view that's much more general. And in doing so, I find that I'm not any longer sure that I'm not just a scientific realist, right? That is to say, if you ask me, do I think there are distant galaxies? Yes. Do I think there are viruses? Yes. Do I believe in unobservables. But with the kind of twist of how the Ontic structural realist thinks, yes. But in the end, this is a kind of scientific realism. I'll just say that now. Right? Now, just to point out then in the abstract. So one thing to say, be clear. Right? So not all structuralists are realists, and not all structuralists are naturalists. Right? Many empiricists and naturalists are sceptical about natural necessity. Definitely not true that all structuralists are realists about natural necessity, but I think this is definitely one thing that Steve and I do agree about. So realism about modality is often associated with rationalism, and in current metaphysics, people talk about distinctive metaphysical modality, metaphysical explanation. Some even talk about metaphysical causation. There's this idea that if you believe in metaphysical modality, you're believing in this separate domain. And okay, good. So what I'm going to argue is that a naturalist defending Ontic structural realism should commit to natural necessity to differentiate their position from structural empiricism, to make it a realist view. But the kind of necessity that I'm talking about is not a sui generis, separate kind of metaphysical necessity. I'm talking about the necessity that's in the modality that's investigated by science. Good. Okay. I'll go the other way. And I want to acknowledge Nora Berenstain. I mean, lots of people to acknowledge, and Steve and Don Ross, most importantly. But also Nora, because I wrote a paper with her that specifically addressed the matter of modality in relation to structural realism. I'm drawing on it here. So, question: does ordinary scientific realism require realism about natural necessity? Surprisingly little direct discussion of this in the realist literature in recent years, I think. It's an implicit issue, though, throughout the debate, and an explicit one when people aren't talking about realism so much, but talking about laws and causation, other topics in philosophy of science. So these people are all realists and anti-Humeans in different ways, but they're all united by their commitment to modality in the world and science telling us about it. On the other hand, these people are all scientific realists and Humeans. And so, prima facie, you might think, right, in that case, scientific realism is independent of whether or not you're committed to natural necessity. And part I want to do is argue, no, it's not. Which means that those people must be wrong. Right? I mean, they're not wrong that they believe scientific realism and humanism, but they're wrong to think that that's intellectually sustainable. Right? And what I would say in particular is that they undercut the arguments for scientific realism with their humanism. But that's going to be very contentious. I'm sure you'll want to fight about it. So that'll be good. And of course, for empiricists, there's this tradition, the only necessity is verbal necessity. Eliminate or reduce all necessity. Whereas the Humean tradition is defined in this context by the claim that there are no necessary connections between distinct existences. So that's what humanism will mean for me. It will mean the denial of necessary connections. And what we'll see is, if it isn't already clear to you, is that denying natural necessity is not the same thing as denying objective modality. And at certain points I kind of thought it was, and so I would say, you know, Ontic structural realism is commitment to objective modality, and I now think that's like necessary but not sufficient, because there are ways to be a Humean but still to have objective modality. So the crucial thing is not just objective modality, it's natural necessity. Okay. The empiricist program of Carnap and others, arguably one of the main reasons it fell apart was failure to account for the modality of science, failure to give it a proper account of laws and so on. Van Fraassen completely repudiates the metaphysics of modality. And he actually takes it as kind of definitive of being an anti-realist, that he rejects it. And this is something that I think hasn't been picked up as much as it should have been. For him, scientific realism is objectionable in large measure because it obliges you to have a metaphysics of modality and to take modality seriously. So, part of my overall argument here is that Van Fraassen's right about that, but wrong to repudiate it. So, and they say, yeah, he is right. If we're scientific realists, we're going to have to be kind of up to our necks in natural necessity, certainly in objective modality. But that's okay. Interestingly, everyone knows that Van Fraassen is better thought of as an agnostic than a denier of the existence of unobservables, right? So, you know, remember the quote actually that Kerry had yesterday, where he says, I am merely agnostic about unobservable things like electrons, but I'm damn sure there's no sense data, right? So he's very self-conscious. Was it you? Sorry, I'm getting confused. I don't know who is going to feel upset about my confusion. You're both really good talk, so I think you're both okay. Yeah, that's right. Sorry, it was you, Simon. When it comes to modality, most of the time his official position is, actually it's hard to say. His position is kind of ambiguous between agnosticism and outright denial. Right? I suspect that what he really goes for is the outright denial. There is no natural necessity, there is no objective modality. So on the anti-realist side, it's natural to associate the denial of scientific realism with the denial of necessary connections in nature. Now, let me say, I'm going to come back to this issue, but now let me say something about naturalism and realism and structuralism, because there's a lot of confusion around, I think, because so many people call themselves structuralists in different ways, and let's just point out then, not all structuralists are naturalists. Take Michael Esveld, for example. He's defending Ontic structural realism. He, I would argue, is not naturalistic, right? I mean, the reason being that he defends his picture of the world as one which is compatible with any possible future revisions to physics, right? Compatible with any version of physics. So therefore it's not motivated or tied to the current state of scientific knowledge. And I think that if you're a naturalist in metaphysics, then your position should be motivated and tied to the current state of scientific knowledge. Note also, so this slide came in the wrong order, sorry, that's a separate point here now. Not all structuralists are realists. So Van Fraassen calls himself an empiricist structuralist. Tom Reichman is a kind of neo-Kantian structuralist. So really, naturalism, realism, structuralism, they all come apart. Right? So there's not a deep point, it's just important that we know that, so we don't run people's positions together. Now, Steve is also not a realist about almost all, if not all, of scientific ontology. How does that? I mean, he may say, being too quick, but there's no point anticipating what Steve will say in my talk. I'll just let him speak for himself later. But my claim is that his view ends up not being realist about most, if not all, scientific ontology. But that's not something that's specific to him as a structural realist, because in fact lots of scientific realists are anti-realist about lots of science, which is kind of odd. So I want to defend my view, the view that I developed with Don Ross, as both naturalist and realist and structuralist, obviously. And when I say realist, I mean ecumenically realist. So the really, sometimes people say to me, oh, you're just a massive reductionist and you think everything is determined by how physics is, and it's like, no, it's the opposite actually. I'm a radical anti-reductionist in the sense of thinking that the ontology of the special sciences is on a par with the ontology of physics. Right? There's no second-class ontology. So I don't want to be an eliminativist or a reductionist about viruses or galaxies or tectonic plates, or any of the lovely things that we wouldn't be able to even mention if we didn't have science. I am a realist about those things. And what I'm going to argue is really that the kind of Ontic structural realism I have is, even if you don't buy that it works, I want you to at least understand that the reason why it's done the way it's done is so that it can succeed in this ambition. Even if that fails, it's motivated by trying to construct a position that allows you to be a realist about the whole lot. Now, one of the things that motivated us, I think Steve and I, in going for a metaphysical version of structural realism. So Ontic here in the broad sense of Ontic structural realism, in the broad sense I mentioned yesterday, which is something like ineliminable structural commitments, or ineliminable structure, ineliminable relational structure, something like that. Right? It's motivated by thinking about physics. So yes, of course, physics has played a role, but that's not the only role, or the only motivation. Okay, now Van Fraassen has this challenge, and this is so there's a sense in which what I'm saying here is nothing new at all. It's all kind of implicit or explicit in other writings. But this is a somewhat dense book, and I would write it probably differently if I did it now. And I don't blame you if you haven't picked through it and worked out exactly what I believe. So I'm just going to try to pull out things to make it clear what I think. But one thing, and so this is a point that goes way back. And Steve and I used to get this objection all the time. Oh, you just think the world's mathematical structure then, right? You structural realists, you think everything's abstract structure. And we said, no, you don't think that. Because what? Well, because let's say the structure of an entanglement relation, that is an abstract structure, that's concrete structure, that's in the world. It's contingent that any bit of it obtains. And it's nothing to do with, it's not pure mathematics, it's not abstract. So, French and Ladyman, 2003 or something like that, I think it was,
yeah.
we said there, the structure we're talking about is the objective modal structure of the world. And what I want to say, part of what I will say today is, yeah, but actually this phrase isn't good enough, we need to say natural necessity instead. So this is still true, but necessary but not sufficient. But yeah, so that's just an important point. We've always said we're talking about the objective modal structure of the world. Now, clearly, of course, you could go the other way. Right? You could be an anti-naturalist philosopher who was a realist about natural necessity, but just didn't think it was described by science, right? So you might think something like, oh no, the real locus of natural necessity is in agents and their actions or something, right? The life world, and that would be an anti-naturalistic, realist view of natural necessity. So, no necessary connections between distinct philosophical theses when we're careful. We can see that all these things are separate moving parts, right? But it's also, of course, possible to deny the existence of natural necessity while arguing that, and this is then the point I want to make, that objective modality does not imply natural necessity, basically. So you could say, yeah, I don't believe in any natural necessity, but I also don't think it's arbitrary what the modal relations are, because the modal relations are reducible to objective facts that aren't themselves modal facts, right? And that's the sophisticated Humean picture, or the sophisticated Humean picture is a version of that, right? So the sophisticated Humean story is something like, there's the world, there's all this stuff going on, there's a maximally simple and scopeful way of describing it. Once we've written that down, then what's necessary is what follows from the axioms that describe the world as it is in the most simple and scopeful way, and that's a perfectly objective fact. Right? What those axioms are is perfectly objective. So we have objective modality but not natural necessity. Okay? So Stafford Sillos would say this, right? He says this explicitly in his book Causation and Explanation. He said, I'm a realist about the nomological structure of the world, but I'm a Humean. There's objective modality, no natural necessity. Good, so then they think, I mean this second paragraph just says what I've already said, so you don't bother reading it, but the point is they can then avail themselves of the explanatory and dialectical advantages of scientific realism without incurring the metaphysical cost. That's what they say. So, what I'm going to do is, won't have a huge amount of time, so I'm going to sketch and advertise why you might think that scientific realism required natural necessity. And then I'm going to also sketch and advertise my version of Ontic structural realism and just explain how it's motivated by problems other than those to do with fundamental physics and non-individuals in quantum mechanics or whatever. And then I'll stop. So, claim. Scientific realism requires both for its defence and formulation objective natural necessity. Okay? Don't think I'll give you arguments sufficient to establish that claim. And I'm really going to sort of gesture at my arguments rather than just repeat them. But I just want you to know that I think this is an important point. So let's take an example. Well, the main motivation of scientific realism in general, structural realism in particular, is the no miracles argument. And the no miracles argument says, in its prima facie form, crude sort of form, the long-run novel predictive success of science, repeated novel predictive success of science, because remember the no miracles argument is a general argument about science as a whole. It's not just about some specific bit of science. And in particular, the way that theory-laden methods lead to the development of new theories, and the way that background theories and auxiliary hypotheses are involved in the generation of new predictions. Right? So it's an important point because Richard Boyd made this sophisticated version of the no miracles argument. Right? He says, no, it's not just about truth explains success. There are very specific aspects of the way that science works that we need to explain. In particular, we need to explain the way that new theories are tested assuming old theories, the way our instruments rely upon old theories, the way our methodologies are theory-led, and so on. All of that is best explained by our theories getting things right about the world, but getting things right doesn't just mean listing what objects there are, right? Because that wouldn't explain how we're able to make predictions. What's important is that we get things right about how those objects behave, how they interact, and how they cause phenomena. So it's the causal structure of the world that we're latching onto. So this is the kind of thing that people would say in literature. If our theories weren't latching onto the causal structure of the world, then how come they could be so novelly predictably successful? So at least prima facie, the no miracles argument makes reference to science's descriptions of the causal structure of the world, the law-like structure of the world, what I would call more generally modal structure. And indeed, of course, laws are central to science. So if you think about the role that modal notions play in science, then they're absolutely fundamental. Right? If you're going to be a realist in the broad sense, you take science at face value, believe in scientific knowledge, then on the face of it, that scientific knowledge includes knowledge of modality. Scientific journals and textbooks are awash with causal claims. Much important scientific knowledge takes the form of attribution of causal powers to things. And let me just mention a couple of other things that aren't so often mentioned here. So probability is now absolutely fundamental to science. Well, probability was on Aristotle's list of modalities with good reason. Probability goes beyond what's actual. Probability generates opaque contexts, right? Intentional contexts. So it was improbable in 2005 that the next president of the United States would be an African American. But it wasn't improbable that Obama would remain an African American. So substitution of co-referring terms gives you change in truth value, right? Now here's another example of a kind of explanation that seems to be sort of sui generis explanation in terms of modality. So this is from Elliot Sober. When he talks about the importance of, and this is why I would go beyond just talking about causation and causal power. So I think where I would sort of agree with Anjan is in the importance of causal powers in science, but where I would maybe depart would be that I would think, yeah, but there are some things that aren't expressible in terms of causal powers. You need a broader notion of natural necessity than just causation. You need law-like, but you also need probability, you also need equilibrium explanation, right, where the particular causal explanation of the phenomenon isn't the relevant thing, because the event would have occurred had very different causal scenarios unfolded. The event would have occurred in more or less the same way because it's an equilibrium. So, I mean, this is a very important aspect of explanation in biology, but also in social science. When you think about something like landmines, nuclear weapons, chemical weapons, pretty easy to see that you gain a lot from the concept of equilibrium, right? There's two equilibria, one where everyone's got them and uses them, and one where nobody's got them and uses them, right? That's why it's absolutely necessary to impose from the outside which equilibrium we're going to be in. Have a treaty against landmines or a treaty against poison gas, because it doesn't really matter the causal pathways, exact nature of the causal pathways. We're going to end up in one of those two equilibria, and we don't want to end up in the equilibrium where everybody uses chemical weapons every time there's a conflict. So understanding the kind of structure of that scenario requires you to have an idea of equilibrium explanation. It generates a kind of necessity, but it's not causal, or at least not in the ordinary sense of a causal explanation. And symmetry explanation, I could tell a similar story about that in physics, but I'm not going to. Okay, now, so that's just like and I mean, I told you I was only going to advertise this, and that's just a sketch of why I think that not believing in natural necessity, or at least objective modality, but I'd have to give you my arguments against the Humean view to establish natural necessity rather than objective modality. We've got time for that now, but I just wanted to give you a sketch of why is natural necessity, objective modality, so important to the structural realist. And the argument is because it's always important to the scientific realist. Right? It's important for the motivation for the position, and also for the statement of the position, and also because in large part science is about modal structure. So if you're a realist about science, you've got to be a realist about that. Okay? So that was what all that was about. Now, let's just be clear though, of course it's not true that the modal structure of past theories is retained and the substances aren't or something. That's, I get this kind of, this is what you think all the time, that structural realists think that you can look at past science, divide it into structure and non-structure, and then you claim that the structure is retained and the non-structure isn't. There's a terrible, that would be a really silly position to have. Like, why? Because the structure of Newtonian mechanics has not been retained, right? The structure of our past theories is not the same as our structure of our present theories. The point is rather that when we just think about ontology or deep metaphysical claims, then it's hard to see how there can be any approximate truth. But when we go to structural relations, we can. So we can, and again, this is naturalistic, right? Physicists exhibit the continuity with past theories in structural terms. So that's how they do it. Right? They show that the laws of the old theory are retained as limiting cases of the laws of the new theory. Or they show why the old theory holds in some domain or some regime using the new theory. Right? So the link is built at the level of structure, not at the level of metaphysics. So what that means is that in a dialectic with the anti-realist, where the anti-realist says, but look, past theories abandoned their theoretical, we've abandoned the theoretical claims of past theories, so all we know is the empirical phenomena, we can say, no, we have retained more than the empirical content of past theories. Right, what? Well, Newton's law of gravitation is more than the empirical content of Newton's mechanics. Right? What appears in general relativity is an equation that's the low energy limit, which basically expresses Newton's inverse square law. So what's emerging in general relativity is not something empirical, right? Part of the theoretical structure. So the claim is again a kind of negative one, right? That it's, or at least it's removing a barrier, right? So the barrier was supposed to be, but we can't understand how there can be continuity between an elastic solid ether and the quantum electrodynamic field, right? And the response is, yes, but can you understand how transverse wave motion of light and the association of light with electromagnetism can be retained by your present theory? And the answer is, yes, we can. So we're able to undercut the anti-realist argument that says there's no continuity other than just empirical success, empirical predictions. So we really don't think of it as much more than that. So the first quote there is from, a quote at the top here is from Ladyman and Ross on the table, and this is a quote from French and Ladyman. And this is from 2006 or so. When did we write that paper in defence of Ontic structural realism?
One in the Apocalypse one?
Yeah, after Banff.
That's like 2010.
2010, right, something like that. So there we said, here, very clearly, the job of structural realism is not to say in advance what will be preserved in our best current science in the future. Right? If we could do that, if I could look at the standard model and tell you what will be retained in the future, I would be on my way to getting a Nobel Prize in physics, right? Because if you could say what will be abandoned, you'd know where the new physics needed to be. And I don't know that in virtue of being a structural realist. That's mad. But yet loads of people say, oh, that's what you think you can do as a structural realist. You think you can look at science and tell us what will be retained. It's like, no, I can't. What I can say is, I'm really sure that more than the empirical predictions of the standard model will be retained. Right? I think that the theories of the standard model will be retained in the regimes for which we're sure they're applicable, and within the energy ranges and scales that we think they're applicable. But there may be some things that we've got really fundamentally wrong, even empirically. After all, Newtonian mechanics is not just a little bit wrong about relatively fast-moving things. It's completely wrong. Right? Newtonian mechanics isn't a little bit wrong about really small things. It's completely wrong. But it's still true that, and it will always be true, that if you're building a bridge, then you're going to quantify Newtonian forces. Right? And you're going to use Newton's mechanics. Now, why is that? Answer, because it describes real patterns. And that's really not an answer. It's just a label. Right? But I'm going to say a little bit about the real patterns view. And why is the real patterns view needed? Well, look, one thing that scientific, what we often do in philosophy, we sort of we get inside one debate and we only think about the problem in that arena, right? So the problem in philosophy of science is scientific realism versus anti-realism. But what we need to do is think about that in the context not just of arguing about anti-realism, but also thinking about, yeah, but how does common sense ontology fit with scientific ontology? How does a scientific realist picture accommodate that? Do you have to eliminate common sense realism? Now, interestingly, in one mode, loads of scientific realists will tell you that scientific realism is just the extension of common sense, right, and common sense reasoning. So they'll say things like, well, look, if I go in the woods and I see bear tracks, then I'm perfectly entitled to infer there's a bear. Yes, it's underdetermined, but so what? Doesn't mean I can't know that there's a bear there, right? So scientific realism is like an extension of common sense realism. Because it's an extension of, common sense. It's arrived at, the realist commitments of science are arrived at by similar methods to the realist commitments we have in everyday life. But, on the other hand, scientific realists will often tell you that science has taught us that there aren't really any tables or bears or whatever, right? And now they seem to be cutting the ground from under their own feet by doing that. So, therefore, they need to have some story about how the scientific image and the common sense manifest image relate. They also need to have a story about how past and current theories relate. We've already just talked about that. They need to have something to say about how the sciences at different scales relate. And, Fred was saying that everything must go is constructive. I mean, there's loads of positive theses in the book. So, Kean Dorr wrote a review, so he said there are no theses in this book that are clearly enough stated to be worthy of arguing with. And so I thought, well, a good way to write a response to that would be just to enumerate theses that I think are fairly clearly stated in the book and worthy of arguing with. I got to 15 or 20 and I sort of stopped. I think I got to 20. 5 were negative theses and 15 were positive ones. And one of the most important is that we should be we should adopt what we call the scale relativity of ontology. Right? And I think this is an important idea in the book. It's very prominent in the book, and it's one that almost nobody sort of noticed, I guess. And so I want to emphasize it here. And I'll come on to that in a minute. And then the other thing, and these problems, this problem and this problem are obviously closely related. We need to have something to say about how the ontologies of special sciences and of fundamental physics are related. So, what I'm arguing is that the real patterns view is trying to address all these problems at once. Right? And you might think, okay, well, you're going to fail, you can't do it, I don't believe you, it's too ambitious. Right? But I just want to explain that that's what we're trying to do. So I also think those problems are related. Right? So Why? Well, in many cases, the strongly empirically successful theories of the past are also the theories presently used in some restricted scale. Right? So, for example, Newtonian mechanics used at relatively low energy scales and relatively medium length scales. Right? So not really, really big, not really, really small. Newtonian mechanics, Ravenway optics, classical electrodynamics, classical statistical mechanics are all still used. The ontology of such theories remains effective in the sense that the entities it posits are part of empirically successful descriptions and models. So what I'm arguing for, our people have coined the term effective realism. All right, well, yeah, okay, but do we need another name? I mean, I don't know whether maybe I should just abandon Ontic structured realism and just say this is just the right version of scientific realism, right? Because it just, otherwise, but I get it, everyone needs their own theory, but really, the idea of effective realism is just the idea of realism within some domain at some scale, in some regime. That's all it really amounts to. And you might get to that by thinking about effective theories in particle physics, but you could just as well get to it by thinking about Newtonian mechanics or wave optics. So here's an example. In the theory of superconductivity, we treat the condensed matter as a lattice of sites in which there may or may not be pairs of electrons, and interactions between them are mediated by phonons. And phonons are treated as if they're genuine particles in the model. They are called quasi-particles. What's a quasi-particle? It's a particle whose half-life is effectively infinite with respect to the scale, the time scale of the interactions in which you're interested. Right? So if the particle may as well be treated as just being there forever over the kind of time scale that you're studying, then it's a particle. Phonons are not taken as fundamental, but then even protons are not fundamental. Right? In general, in particle physics, you can say something like, we have particles when we can write down a Lagrangian in particle degrees of freedom that's empirically adequate, right? That describes the system. Good, so now notice that the entities that we now regard as emergent and effective were also once the entities that we thought were the fundamental things according to the past theory, right? So at the stage when we thought, right, so there's protons and electrons, that's it, right? We thought those are the fundamental things, and now we think, oh, yeah, protons are emergent effective entities, right, relative to the quark model. So that's what I mean about these different problems being connected, right? The problem of ontology in different sciences, the problem of ontology at different scales, the problem of ontology of past and present theories, these often overlap. So solids and liquids, magnetic and electric fields, they're part of the effective ontology of condensed matter physics. None of these things are part of the ontology of quantum field theory. In this sense, much of physics is like special science. The special sciences in general deal with a plethora of emergent entities, properties and processes, and so does physics. Right? And this is the one thing one of many things I would change about the book is that I would never say fundamental physics anymore. I would say something like more fundamental physics, right? Because what we have is this continuum. There is no finished physics. It makes perfect sense to talk about fundamentality, but almost always the sense that can be made of the scientific usage is, or at least the scientific usage is actually warranted by the practice of science, as opposed to kind of science overreach, is fundamental with respect to those other things, more fundamental. In other words, fundamental is a relation rather than a sort of absolute notion, right? So it is true that quantum electrodynamics is more fundamental than Maxwell's electrodynamics. But it's not true that it's fundamental, because it's the product of the broken symmetry of the electroweak theory. Right? Now, scientific realism as such has no account of the relationship between ontologies, nor of the relationship between causation and law at different levels in different sciences. And this is problematic. Recall Eddington's famous two tables problem. I would pose the problem not in terms of the table, but just in terms of the ontology, because rather than just stay clear of common sense and the manifest image, all those extra complications, and just raise it at the level of, well, what's the relationship between the gas and the molecules, or what's the relationship between the condensed matter and quantum field theory? So arguments for realism based on causation, intervention, explanatory power in theories dealing with emergent phenomena only establish effective ontology. And then what I'm really thinking is like, yeah, but we only have theories of effective phenomena. Therefore, all ontology is effective ontology, right? So we should sort of stop worrying. But we have to, you know, get rid of the kind of fundamentalist hangovers in the way that we think about this stuff, right? So we shouldn't ever say things like, all there really is are atoms, right? But that's not justified at all. Right? There are emergent effective entities, and atoms are among them, and so are tables. So many philosophers, scientific realists among them, argue for the elimination of all such entities in favour of the fundamental physical stuff. It's often argued that emergent entities lack any genuine causal powers. You get kind of generalisation of Kim's causal exclusion argument. All genuine causal powers must reside at the fundamental physical level, so all this other stuff is just pragmatic. And then you might say, I'm not interested in that because I'm only interested in my metaphysics isn't pragmatic, it's about what's fundamental. I mean, to which I would say, okay, fine. But meanwhile, I'm still interested in the difference between unicorns and horses, right? Which I mark by saying unicorns are not real and horses are, right? So, is that just pragmatic? I would say no. It's because of how the world is. And if we end up saying the only things that are really real are the things that we don't know anything about, even whether there are any such things, well, perhaps that's not really what we should be using the word real for. Perhaps we should stick to using the word real for what we ordinarily use it for, which is marking differences like the difference between unicorns and horses. And so we might say now, you know, is a first order question in science, is there a planet around that star? Right? Is there a gene that's strongly associated with that illness? You know, about reality, it's about existence, but not in the ultimate sense that some people seem to understand, which I'm not sure I do. Now, more generally, you can hardly defend scientific realism as an extension of everyday ontology and reasoning to the unobservable if the everyday objects are supposed to be eliminated in favour of fundamental physical entities. I already said this. You can't defend scientific realism by appeal to the first order practices of science if they can be taken as delivering ontological commitments that ultimately be repudiated as mere epistemologically useful fictions. Right? So there's no point in one mode running an argument for scientific realism by talking about success and novel prediction and so on, if then in other modes you say, oh, by the way, none of that stuff exists. So I actually think, you know, it's very ironic that scientific realism taken to extremes is now the major form of instrumentalism about much of the ontology of the special sciences. Right? So you buy into scientific realism, then you convince yourself that the only thing that exists is the fundamental physical stuff. Then you repudiate the existence of almost everything that's described by science, but you still call yourself a scientific realist. No. So anyway, at least I hope you see that there's a conflict between fundamentalism and realism about the ontologies of the special sciences. But it's not necessary to advocate disunity or a patchwork view to reject fundamentalism and reductionism and to maintain realism at the level of special sciences. What you need is this real patterns idea. So Let me just say a little bit more about this, and then I'll stop, because I think you can have a good discussion. I'm sure I've said enough to provoke you. So what's a real pattern? Well, roughly something that makes for a simplified description relative to some background ontology. And in this way, I think it unifies this kind of idea of structural realism in terms of real patterns, unifies entity realism with structural realism. So this is why I said in the end, I think I'm a scientific realist now. So let's take an example. A wave on the beach. Okay? Is it an object? Is it real? Well, it's taken as the basis of predictional explanation. It kind of on the borderline, it persists for long enough. But maybe a sandbank, well, that's definitely real. But they move, they shift, it's just a matter of timescale. There's a vague boundary here. If you're thinking over very long timescales, then you're not going to regard sandbanks as real, or waves. But nonetheless, in a relevant domain, over a relevant timescale, there are interactions such that it is as if that thing lasts forever relative to the timescale of those interactions. Right? So if the interaction is the surfboard, the wave picking up the surfboard and smashing me on the back of the head with it, then it's of very little comfort to me that the surfboard is ephemeral, that the wave isn't durable. It's durable enough to hit me on the back of the head with the surfboard. So the point is supposed to be, the wave is like the phonon. Right? It's a scale relative thing. And the different sciences have their different characteristic length and time scales. So my favourite examples is geology. In geology, an instantaneous process is one that takes place over the order of about 1 million years. Right? So, in cosmology, a great example in cosmology is the idea of a gas in cosmology. Right? So I remember asking these astronomers, you're talking about these gases. Just how many molecules are there? They said. If you take a cubic meter of an astronomical gas, and it is orders of magnitude a better vacuum than any vacuum we've ever made on Earth. Right? The average, if you randomly pick a square meter of astronomical gas, there's overwhelmingly not even nothing there. Right? It's just that when you're talking about a gas in astronomy, you're talking about length scales that are like hundreds of thousands of miles. And then there is a gas. Okay, so so what we argue is ontology is scale relative. What does that mean? It means that if you go to a different regime, the ontology might just disappear. Right? So when you're climbing Everest, quantifying over the mountain is completely useless. Right? There is no mountain. When you're climbing Everest, there are peaks and ridges and valleys, and the whole topography opens up, and the idea that there's just like mountain, not mountain, makes no sense whatsoever. Right? And I think this is sort of generally true, right? You zoom in, and your old categories just become inapplicable. There's at a very, very small length scale, there's no place where the table starts and ends. So, real patterns are entities of whatever ontological character that that feature non-redundantly in projectable regularities. And this is very similar. I've got here very similar view to what David Wallace argues. And David says in the argument with Doreen Fraser, to which you were referring, particles are effective emergent entities. That's it. Don't get worried that we can't find them as kind of absolute inviolable things, because that's not what they are. So you could interpret all this as just an account of the pragmatics of some kind of ultimately epistemological kind of emergence. Like, you're just telling us about the stuff you have to talk about to do the bookkeeping, right? And that is what I'm telling you about. But I think that's what ontology was always about. And that's what all ontology is doing. And if you regard that as a kind of second-class ontology, then I suppose I'm sort of skeptical about anything else other than that. I don't see the contrast class. I give examples of what it might putatively be if there were any such things, but I don't believe in any of that other stuff. So yeah, this is it. There isn't any more to reality than that. There may not be a fundamental level. There may not be ultimate individuals. I mean, maybe there are, but let's not build, and I got this from Jonathan, and I'm sure he hates what I've done with it, but it was the first paper that I ever read that said, hey, everyone talks about this fundamental level. Do we know there is one? Why should we think there is? And it was like the scales fell from my eyes. I thought, that is that's an implicit assumption I've been carrying around with me. Always thinking in terms of this fundamental level picture. Okay? But now I've liberated myself from that. Okay? So that doesn't mean that I'm sure that there's no such thing, because that would go to way beyond the bounds of what I can know. But it does make me think that I shouldn't presuppose that there is such a thing. And I certainly don't think I've got any scientific reason for believing in such a thing. And in a way, I mean, I think I would take something like, Jonathan himself has defended this kind of monistic view. All there is the whole of the, I mean, I don't know if I've got this right, but there's the whole thing, there's the whole of reality, and then we can predicate of it, and that's it, right? That's the object. And I can sort of think, yeah, that's sort of, the fact that that's the view you're defending kind of fits with my story, right? Because it's either that or this effective emergent stuff. The real patterns account explains why we don't abandon old ontologies in much of scientific practice, because if it was a real pattern and we had good evidence it was a real pattern, then it's always going to be a real pattern, right? What we will discover, though, that is more about, in which regime, under what conditions, to what degree of approximation. So, yeah, good. Now, since everyday objects and their properties are also projectable in various ways, the real patterns account is also applicable to common sense realism. So it solves that Eddington problem. And the reason we talk about tables is because there's an effective description in terms of the degrees of freedom of the table as a whole, which is really good for predicting the dynamics of the table at a scale where I don't care about what individual particles or components of the table are doing, I just care about the table. Right? Why would I model it with all the parameters that are used to describe, that would be needed to describe all its parts, when there's that contingently, because it's a real thing, right, those parts are bound together in such a way that I can just quantify over a much fewer number of parameters and get an effective law about the motion of the table. So it's a real pattern at macroscopic scales, but not at microscopic scales. There's a rough correspondence between lots of everyday objects and physical objects, because lots of everyday objects are bound states in the technical sense. But that's not going to be enough for most everyday ontology, because lots of everyday ontology individuates things in functional ways. So, for example, a suit is a single object, even though the trousers and the jacket are not in a bound state. Right? So lots of everyday ontology is individuated functionally, not just this way. But lots of the, I mean, it's very, I wrote a paper with Jonas Whitaker about everyday objects. It's really interesting. So if you look in the current literature, people talk about everyday things. They tend to sort of think like macroscopic, who was it said medium-sized dry goods? I mean, it tends to be that sticks and stones. But you go back a bit further, and you look at Gilbert Ryle talking about everyday objects. He's like, yeah, smiles, puffs of smoke, right? So his idea of everyday objects is just like things we ordinarily talk about. Okay, now, problems of vagueness of composition and identity over time, as well as problems of vagueness of generation and corruption. So when exactly does the table go out of existence if I set to it with an axe? When exactly does the table come into existence when I'm building it? Is there an incomplete table with a missing leg, or is it not yet a table? Right? Pseudo problem! Those problems all apply to special science objects and everyday ones, and the solution I'm proposing here is no solution at all. It's just to give up on the demand that the problem be solved. You know, what's your purpose in answering the question? Are we on Everest yet? Right? Well, it just depends what we're talking about, what we're doing, what our plans are, why we care about the question, why we care about Everest. So, claim is real patterns account, obviously unified solution of all these problems. And again, yeah, you might think really ambitious. I haven't said nearly enough about it. That's all true. I really just what I wanted to do was clear up some maybe misconceptions that arise. So one is, structural realism is not selective realism. Two is structural realists don't have to be overgeneralizing from physics. It's not just about physics. Three is structural realism is not the view that the world is made of mathematics, because we always said we were talking about the modal structure of the world, not about abstract structure. And yeah, sketch the real patterns account as emphasize scale relativity. And then I'm saying this is the right way forward. Obviously there's a lot to do to make it really precise. In the book, we give a kind of theory of real patterns. I think it doesn't work. So we've got to think hard about the definition of real pattern. Does it have to be done in information theoretic terms? Maybe not. If you notice, I did it in both dynamical terms and information theoretic terms. So sometimes I talk like, a real pattern is where compressing information. And sometimes I talk about a real pattern is when there's a lower dimensional dynamics, right? Well, those things are related, but they're two different idioms. And another idiom you could use would be an idiom of statistics. Right? You could say a real pattern is non-redundant statistics. Note though that when we talk about composition, in science especially, the timescale is very important. Right? Things that we think of as made of parts, yes, they are, but the parts are interacting, and that's how they compose the whole. It is not the case that we just have the parts there and then some abstract fusion relation or something, and then we get a whole. It's like, no. What binds the table together is electromagnetism, right? Interactions. Those are what make things hang together, right? And we have separation of timescales. This is an extremely important phenomenon. When we get separation of timescales, we get structure, right? One of the main problems at the moment is the collapsing of timescales. So, for example, there are lots of meteorological and geological or geophysical processes that were decoupled and happening at very different timescales and are now happening. Now the timescales are getting coupled and we're losing structure and stability, right? So, the climate system starts to fall apart when the short timescale processes and the long timescale processes get coupled. Thinking about timescale, I would plea and about interaction and dynamics is essential for thinking about composition in the actual world. That is what composition is almost always about. And then seeing that the reason we can talk about the higher level entity as if it was just a thing is because the interactions that are taking place within it are happening on very, very short timescales compared to the timescale over which we're considering the thing as a whole. Good, okay, I've said that. So, in any case, whether or not you believe my particular account, I hope you'll agree that the scientific realist needs to have something to say about the ontology of different scales, ontology at different scales in different sciences. Eliminativism about emergent ontology, I think, sort of undercuts the arguments for realism, right? Because you build your arguments for realism by talking about the success of science, and then if you then end up eliminating that ontology at that level, then, well, then it turns out you can be successful without knowing anything about what's there. So, why are you a realist? Reductionism, arguably not plausible. Well, I think, yeah, definitely not. Now, many people go for pluralism as a result of all this. Well, I mentioned Paul Teller there. I would say, no, pluralism is going too far. One thing is that while there are multiple models offered at different scales and different regimes, that doesn't mean in general that we can't have definite grounds for theory choice among different models. You know, not anything goes. Also, we need to take account of the special status of physics. It's very kind of fashionable at the moment, people to say, oh, physics is just one among the special sciences. And I often hear that claim. And I think it's partly because of philosophers of science who study other sciences sort of feeling that philosophers of physics can bully them by telling them about what's fundamental or something. But you know, just think about it for a moment and you see this is just not true. Say to a biologist or a chemist, please do all your biology and chemistry in complete ignorance of physics. They would say, no. Why would I do that? That would make my science much worse, right? Physics is, rightly has a special status in science. Saying exactly how we kind of tread the line between a reductionism and emergence, it's a complicated business. But the solution to it is not just to say, right, so yeah, it's all, there's no structure at all, it's all flat, there's no asymmetry. So, this real patterns account permits an understanding of scale relativity. It's compatible with weak physicalism, and modality is the key to it, because the relevant notion in the notion of real pattern is the idea of the pattern being projectable, and that's a modal notion. And, by the way, this also explains why focusing on issues of reference cross-theory change is a red herring, because reference can always be secured to some extent whenever there are real patterns that are carried over as approximations. So the issue that we're left with is, does effective ontology deserve to be called ontology at all? Is this all just bookkeeping, like Kelvin said? Well, I'd say no, but then if you really want to solve that problem, you've got to have something to say about the causal exclusion argument and causation at different levels. I haven't said anything about that, so I haven't sort of finished my account here. But anyway, for both French and Ladyman, Ontic structural realism has been from the outset about modal structure. French is an eliminativist about ontology accepted structures of physics, but the real patterns account is ecumenical. But on the other hand, there are alternatives to structuralism involving these more specific ideas of natural necessity. My basic argument is that's all good, but it's just too restrictive, and what we need is a very liberal notion of natural necessity and modal structure. So fine to talk about causal powers, but not universal. Because there are lots of things in physics that don't fit well with this language, I think, and fit better with the language of symmetry and law and so on. So we should just broadly be realists about modal structure. At the very least, anyway, I'll end by saying at least all of what I've said seems to lend credence to Van Fraasen's claim that scientific realism is essentially a metaphysical position of some kind, and in particular a position about modality. I think As I'm pressing this and nothing's happening, I must be done. I'm no sense of how I stood. That was probably a bit short, wasn't it? Short is good, though, isn't it?
No, it wasn't over.
Steve,
Hey?
You went over.
I went over.
Hour and 10 minutes.
Yeah.
That was an hour and 10 minutes. You're kidding.
And I would say
Up
that.
there.
God, time flies when you're having fun. Sorry, I'm really sorry. You should have shut me up.
You started a bit late.
yeah, so Stephen French was your thesis supervisor, right?
Stephen French, I learned everything at
Yeah.
uni. Like Anjan, when I was like,
I'm very invited now to give this a psychoanalytic story about how this works. But I won't do that.
no, that
okay.
doesn't explain why,
No,
why
no,
Stephen didn't agree with
Of
me.
course not. We only have 20 minutes, and as the sort of the newcomers to a philosophical conference, they will witness that an essential property of philosophers is they just cannot ask short questions and give short answers. Everybody has to give their own mini lecture every time, and I'm going to be very severe now, because after 20 minutes we're going to stop. Carrie number 1, Kelvin number 2, Guido number 3, Simon number 4, Anja number 5, Manoli number 6, and so this is roughly 18 minutes divided by 6 is 3 minutes each. Go ahead.
Thank you, James. So I wanted to kind of try and get clear on the way in which physics is privileged,
Yeah.
right? In this context, you said you're ecumenical about ontology, the ontology of effective theories is ontology on a par with other ontologies. Well, classical physics is an effective theory. It's an incredibly useful theory for doing all sorts of science with. You kick off everything must go, castigating metaphysicians for basing their metaphysics on classical physics.
Oh,
So how does that work?
good. Right, so one thing is, they don't base their, it's not classical physics, right? So,
Some of it is.
oh, hold on, but let me just, metaphysicians often taught that classical physics was the physics of point particle mechanics, right? But classical physics obviously includes continuum mechanics, includes fluid mechanics, right? They're not basing it on that stuff, right? What they're usually basing it on is what we castigated people for was the idea of basically fundamental particles as building blocks. That was what we were objecting to, and what we complained about was this sort of unstable combination of old physics, the manifest image, and philosophical physics. So, yeah. So does that answer the question?
So I mean, it seems that part of the criticism is that right, maybe it doesn't point particles moving around in space isn't all of classical physics, but it's a part of classical physics. And certainly, but if the criticism is that they are not thinking about it in a negative way, they're not thinking about the world in the terms of quantum mechanics. That's for sure, right? So that's absolutely was kind of something that was not going on in certainly analytic sort of metaphysics at the time of writing. And that's the complaint. Maybe analytic metaphysicians can just say, well, you know, we're not paying attention to relativity or quantum mechanics, but nevertheless, we're giving a metaphysics to a good approximate of a certain domain, and that domain exists because classical physics is an effective theory, so
Yeah.
it's all fine. So
Okay. I mean, so one thing is, I don't really the polemic against analytic metaphysics is actually a portion of the first chapter, and it's definitely not
Yes.
supposed to be the main point of the book. But and I do sort of stand by it. But what I would say about that is, if you think what you're doing is sort of articulating the conceptual scheme of classical physics or something, then fine. But really, point particles is I mean, what's important in classical physics is that material bodies can often be treated as if they were a point particle with their mass entirely concentrated at the centre of mass. Right? So they can be treated as if their mass is entirely concentrated at the centre of mass, and then you can model them as if they're sort of point particle planets going around the point particle sun is really good for building a model, right? But it doesn't mean in any way that your ontology was that the planet was a point. So the applicability of point particle mechanics methods to the interactions of material bodies is nothing like the claim that people in question thought that they were describing point particles, or should have thought that. Now, of course, there is a notion of particle, a point particle in classical physics, but then there were all sorts of problems that were never resolved. The problem of elastic collisions, the problem of what it is for classical particles to touch, the problem of what the grounds and why there's impenetrability and so on. So I suppose I would say, well, look, if you want to do that, if you want to sort of try and articulate the conceptual scheme of classical physics, then fine. I mean, but you shouldn't pretend that you're doing something about some sort of ultimate nature of reality.
So the problem, just false consciousness is not that it doesn't describe reality.
Yeah, it does describe reality up to a point. But only up to a point. I mean, like I say, classical physics always included continuum physics. During the era of classical physics, no one had ever settled the question of, yeah, but what about heat? What about light? What about magnetism? They were always positing ethers and subtle fluids and weird stuff like phlogiston and so on. So I do think there's a bit of a kind of philosophical reconstruction of what physics was like before quantum mechanics, which is really, really misleading. It doesn't have anything to do with what was really going on. It's a bit like when people say, and I've read physicists saying this, I've read physicists saying, classical physics is intuitive, but quantum mechanics isn't. It's like, really? Tell that to Galileo, right? That classical physics is intuitive, and the relativity principle isn't intuitive. So, I mean, what we often call intuitive is what we've become habituated to. It's not something we just come down from trees with. So I think we've got this weird unstable mix in philosophy, because a lot of the time we talk about the manifest image, and that has to do with our cognition and our nature as evolved beings and how we've evolved to perceive the world. And then we've got classical physics, which is not the same as the manifest image. They're not the same thing, right? And then we've got the world, and so you sort of put together a bit of the manifest image with a bit of classical physics, and then you get something that's not really either, and it's definitely not the fundamental nature of reality.
Okay. Going well?
So you mentioned that structural realism is not in the business of telling us which aspects of current physical theory will be retained by future physical theories.
Right.
After all, if it could, you'd be getting a Nobel Prize.
Yeah.
But I thought the idea was not that structural realism was telling us which structures are going to be retained by future physical theories, but it's telling us that structure will be retained by future physical theories, as in the general metaphysical category, as, say, a contrast with entity realism.
Right, and that's not, I'm saying not that.
Right. And so just to add to that, in your textbook, Understanding Philosophy of Science, you do this nice job of criticizing entity realism using the pessimistic meta-induction.
Yeah.
But then I thought you introduced structural realism as a way of getting around that problem.
Yeah.
Does that mean that you no longer think structural realism gives us any good or distinctive way of responding to the pessimistic meta-induction?
No, I do think it does, but not by way of separating out the bits that will be retained and the bits that won't. So what I think is so let me repeat what I said. So what I think structural realism does is it entitles you to say that that more of our best current theories will be retained than just the empirical content of them. So it's a response to the empiricist who says, look at past science and you see that all the theory gets thrown away and what gets retained, the only thing that gets retained is the empirical content, right? And the claim here is just, no, we've got good inductive grounds for thinking that more than just the empirical content will be retained. But I wouldn't say what I'm talking about is a metaphysical category of structure. No, and what I'm really not in any way trying to pretend that in 2000, 2001, when I wrote that textbook, you know, what I'm saying now is just, you know, continuous with that, and I've always been saying the same thing. No, I'm not saying the same thing. Though I think then, you know, obviously I think I understand things better now. In particular, what I think now is that I'm vindicating entity realism in part, right? Because what I'm saying is, if it's an entity that's figuring in, if it's a real pattern, right, then it will be retained as an emergent entity. Now, the problem with the pessimistic meta-induction is like, well, what about phlogiston? So what I'd say about that is, well, nobody ever stabilized around phlogiston. Nobody ever stabilized around what it was. There are real patterns that are statable in terms of phlogiston that have been retained. So the real pattern in question is that respiration, calcination of metals, and ordinary combustion are all the same types of process, and there's a reciprocal kind of process. Now that's a true claim that would be made by the phlogistonists, as saying all of those processes are processes of dephlogistication. And there's a reciprocal process, which is the process of phlogistication. Okay? Now, we could still say that, right? It's just that what we think about phlogiston has changed so much, it seems misleading and not apt to say it. But we've still retained something of there. And we've retained a lot of the entities from before the chemical revolution. We've given them different names, but for example, marine acid, fixed air, inflammable air, those were all entities that were identified in the phlogistonist era that we still believe in. So, you know, I think it's a bit of a moot point whether the ether exists. I would say, look, we could use the word ether to refer to fields. That would be fine. It's not. The important thing is there's a medium that sustains electromagnetic interactions, and electricity and magnetism are linked, right? And those things will just be retained, you know, come no matter what. But I don't want to pretend that I always had this view and then I've just been like, you know, articulating it. And I've really changed my mind in substantive ways. So now I would say, well, I'm more or less an entity realist. What I would still criticise, though, is the idea that you could really separate entity realism from theory realism. The kind of entity realism I've got is tied to theory, because real patterns says you don't have an entity unless you've got some kind of law-like regularities statable in terms of the entity. And so I hope that helps.
Yeah.
Yeah.
Number 3 was
Is it
science.
still going well, Fred?
Well, I think this is going to be the last question.
Okay, I'll take my time.
Yeah.
I think you really put your finger on a fundamental difference between the empiricist and the realist with the objective modality or natural necessity. But I wanted to sort of explore the sort of the commonalities, maybe, and especially contrasting these two positions with the sort of fundamentalist scientific realist. Only the fundamental, only at the fundamental level, that's the real stuff, and so on. And seems to me, what you've been saying about Newtonian mechanics, Maxwell's electromagnetism, and so on. There, we are now really confident that those structures and entities are there to stay.
Mm-hmm.
While if we move towards the more fundamental stuff, well, yeah, I mean, we can expect that some of those structures will survive, but we don't know exactly yet. Which ones might have some pretty reasonable ideas. While I mean, for the fundamentalist realists, that's our best scientific theory. That's what's real, and that's what we should really believe. So it seems to me, and correct me if I'm wrong, it seems to me that the picture you painted is one in which there's a spectrum of structures and entities, some we can be really pretty confident in being realists about, and others we might be more agnostic, and that seems to be, I mean, it's not exactly the observable distinction, but it's there's some overlap. There's the really unobservable stuff, and some high-level entities in the special sciences and so on, pretty close to the observable stuff. Is there a rapprochement between sensible empiricism and sensible realism?
Yeah, I think that's right. So, but I mean, I think it's always a bit silly to think that the argument for theory change just run the same way with everything. So we think, oh, well, you changed your mind about the ether, therefore you might one day decide the moons of Jupiter won't exist. No, that's not going to happen, right? And I guess one thing that's changed in the way I would put my view is it's probably much more emphasising scientific knowledge rather than doubt in scientific knowledge. But I think that comes from sort of liberating yourself from fundamentalism, right? So once you're not a fundamentalist, then you don't have to buy into all you don't have to buy into things that would put me off scientific realism in that form. So then I'm quite happy. So then I can be really surprised if the Krebs cycle was ever not in biology, whilst accepting that we might change our minds about the ultimate nature of what's going on in living beings and the ultimate nature of matter many times in the future. I think that's I mean, look, it's not particularly this position is it's not particularly interesting in a way. I mean, it just. But I mean, I've come to the point. I've been a long time doing philosophy, that on the whole, there's like in philosophy, there's kind of trivial and false, right? And you're just like, which do you want? And so, I mean, or sort of like, if not trivial, then something like, well, sounds all reasonable and obvious once you put it like that, right? I mean, that's what I'm aiming for here.
Okay, Simon.
The only necessities in physics are mathematical. Discuss.
Yeah, I mean, that's the counter-argument, isn't it, right? Where you just, I mean, that's the Van Fraassen position, right? So you can say, what you've got is a world that you've managed to describe, and you've got this theoretical edifice, and within that there are all these necessary connections, and you're projecting them onto the world, right? I'm of the Hertz view, the job of science is to make it so that the relations in the theory, the relations of necessity in the theory correspond to relations of necessity in the world. So I think of logical mathematical necessity in theories as like our representation of something, which is necessity in the world. Of course, ever since Hume, there have been people who've said, no idea what you're talking about, you're projecting, or want to eliminate that, and so on. So we can argue about it. I think it's very, very difficult to make sense of how we behave and act and the things we believe if we really repudiate all necessity. So if we think that, for example, that all the counterfactuals that we make are true or false in virtue of what we hold fixed, as opposed to just how the world is. But there's a very strong intellectual tradition of that kind, and I think these days people like Hugh Price, would really articulated and defended that. It's part of a more kind of global pragmatism and anti-realism that I'm not sympathetic to. But I haven't got a quick argument about that now. I will argue about it all night.
Excellent plan you are. Thank you, James.
Thank you very much.
15 minutes break.
Prepared to see the necessities There's hope for you yet, so the thin edge of the wedge. It's only how you're going to get tripped up. That's the famous equation. Anyone knows it was Erasmus squared.
Yeah, but all I'm saying is that yeah, right. Or you could do
Okay. Because if you want sensible, reasonable, smart.
Yeah, I'm sure you will. And you will return.
Ja.
The jigsaw into
Return
Return to a
vandaag nog iets gaan aanbrengen die niet gepost had. Ook voor een ander, en vandaag hoor ik original.
Oh, nou. Dus,
symmetry.
Denk dat u
people not paying enough
geld over
is the kind of diachronic
Voorbeelden
structure.
structuur van
But within
Ja, nou ja,
structure,
ik leg een nadruk op niet het meetaspect.
modeling of structure, which is the
Ja, je
precondition
hebt het meetaspect en je hebt
for the emergence of further
het
structure.
globale aspect.
I mean, the precondition is the emergence and stability
Je wil iets
of
opzetten in de trant van general
after all.
Dat wordt eigenlijk
Yes, exactly. Well, diachronic in the sense that, you know, that's, you know, cosmology, you know, precedes planetary science or astrophysics, and astrophysics precedes geology. You know, unless you have, you know, there are preconditions for the formation of systems.
Wij gaan meer een beetje survey.
Most straightforward. They can only come into being within a certain range of conditions, and including obviously.
Even in Nederland
voor deze conferentie, ja. Ik denk daar met de plaats aan. Zo doen we het ook in de tijd. Misschien niet presenteren. Met de grote kanten, zo doen we het.
Ga je op je kop verder met van je...
Ongeveer wel, ja. Dus uit de praatje heb je eigenlijk
That
over
gives me, I think, does give me.
interview realism.
Oh,
Interview realism aan de ene kant dan economische acquisities van bepaalde experimentele rechtszaken. Alles is hier zo zijn allemaal ongeveer dezelfde historische thematiek te vinden. Maar dan hier heb ik nog
Dat je het ook aanneemt.
Het blijft wel binnen hetzelfde domein.
Ja, precies. Dus dat gaat van
mijn allemaal
dat maakt iets dat voor deze
They've all been great talks. Amazing.
Ah ja, soms denk ik echt heel vreemd. Dat is ook heel onduidelijk. Ja. Maar als ik dan de juiste geef, wordt het springen, dan denk ik, ja, wel heel redelijk.
Ja.
Ik weet, ja.
Wat zijn nog steeds een beetje, ja. Ja, ik denk als je nou echt iemand heeft en staat op yoga op, dat hij niet gewoon het is niet zo'n view dat alleen maar abstract.
Nee, inderdaad. Ja, dan zegt hij, je kan de real patterns, zowel dynamisch als informatietheoretisch als wat is het eigenlijk? Ja.
No, I was just looking at James's book.
Nee, ja. Nee, het is het idee van een structure of zo. Helemaal. Maar. En jij bent nu aan het verder drukken nog tijdens, of je hebt vakantie nu?
Nou ja, vakantie zou ik niet echt doen, maar ik moet wel gewoon veel verschrijven. Ja. Ik heb eind augustus een hele game week officieel vakantie. En voor de rest, ik heb altijd vakantie, ik heb nooit vakantie.
Nee, ja, dat is waar. Nee, ja. Toch genoeg echt vakantie. Ja, toch een beetje. Het kan wel heel snel wat ja, zelfs als je inderdaad, als je echt vakantie hebt, is het nog niet gewoon.
Ja, en maar ook gewoon in de buitenkant nog even iets in de avond. Ja.
Dat geloof ik ook. Dat is gewoon zo.
Ja.
Dat is die uitspraak. Dat is het fundament. Ik geloof dat er dus dat communistische richting zit. Waar we zeker op kunnen zijn.
How's the recording going? It seems to be going very well. All the ones we've transferred so far seem to have come out perfectly. Unfortunately, we didn't get the, well, we got everything on the first camera, the main camera. The second camera ran out just in the middle of James's talk. We do. This means we didn't get all the audience reaction shots. No big deal.
I'm a little worried about some of the audience reactions.
So he's the one who tells me to get
Shots and people going,
yeah, it's more than 3 You don't want to get
the drool coming out.
We casted a spring bird over that.
Will they be edited?
I hope so. think so. Yeah, they certainly will be on the audit, because there's lots of dead time at the moment, all that.
Yeah. Yeah.
necessity is, dat het is van de wording, die is niet geleverd.
That one's coming down, I need to change the back. That's really getting very flat.
Ja, die was dan niet. Misschien die ruimte. Ja, misschien. Maar het is wel geen puzzel die
State security secrets, yeah.
That's all right, I'm not recording, don't worry.
No, no, it's
I'm just checking to see if I've got the right.
For a moment I was afraid that you might have got only like...
No, I would have let you know, don't worry. I'll just make sure I had the right card in there. No, don't worry. No, you're quite right.
Yeah, this one.